You are seeing my slides?
Yes.
Okay, so, well, let's start with just a short overview of what I will present today. So we'll start by talking about what we intend when we talk about human AI teaming in the manufacturing field. Then I will show you our human AI teaming interaction model. I will go through the various blocks that compose it, and then I will give you an overview on how we are using and plan to use the model in various use cases. So let's start by the beginning. The beginning is that there is quite an interest in introducing advanced systems that include artificial intelligence in manufacturing. And so teaming has emerged as an area of study because this sort of system creates, or rather enable, interaction that are a bit more akin to interacting with other human worker rather than the old paradigm of a worker interacting with a tool. So when we talk about teams in manufacturing, we talk about teams that involve one or more members. Some are human operators and some are AI agents. And these AI agents have a level of autonomy sufficient to make them recognizable by the human operators as a distinct entities that can have a role and that can have responsibilities within a task. So again, something that is more similar to operating with another worker rather than having control over a tool. Now, the level of autonomy is something that can vary a lot. So we start from something that has very low autonomy as a personal assistant that is only doing things if we are asking them, and perhaps is only giving a suggestion, to autonomous agents that are able to take decision and adapt how they operate independently with no human involvement. So on this spectrum, we still talk about human AI teaming. Then, so from this, we decided that we had to develop a human AI teaming interaction model. And the reasons to do so is that we felt the need to develop a tool that would give us a common language, both internally in Deep Blue, but also when we are talking with other stakeholders in a project. A common language that would allow us to describe teaming and that would allow us to also document all the various bits of information that we collect as we approach a use case that we think, based on what the literature is telling us, but also on our years of experience, that can affect teaming. So all the important bits that are sort of contextual to the introduction of human AI teaming that can affect it we try to capture all of these in the model. And once we have all these things, the model allows us to have an overview of how things are interacting with each other. And so if we have an issue, and by issue, I mean, for example, a lack of trust in the AI system, we know which variables we can go and affect to try to fix this. Finally, at the end of the project, we might want to do validation of a system. And this model is also helping us to find out which things are most importantly in that use case to be validated, and also how we can validate them. I'll go again through all of these things as I explain the model. So this is the model itself, and don't worry if it's too small to read. I'm going to go through each block one by one. But the overview is that we have from the outside inward, we have two blocks that are the environment and the task. These are the context in which the team is supposed to operate. So where they are operating and what they are supposed to do. And they are part of the model because we think that the team can be a unit that is asked to do multiple tasks and can operate in multiple environments, but still it's affected by these two blocks. So it is part of the model, but it's somewhat separate. In the middle, we have everything that make up the team. So the two protagonists, the agent and the operator, and what makes them interact, the mediator. So let's look a little bit deeper at each block. First, I would start from the environment. The environment, as the name suggests, is about collecting information on where the team will be deployed. But this is not only physical information, it's not only about the ergonomics and location in a factory, it's about also the cultural organization of the company, for example, internal policies, but also the ethical and legal framework we might have to work within. And as you can imagine, this is quite important, especially now that there are new regulations, the AI Act, that will increasingly regulate how we introduce AI system. So we need to have an overview of that. And finally, we also need to have an overview of what is what are the economical requirements and the performance requirements that might come from the stakeholders. And this is something quite critical because every intervention, like the introduction of an AI system, will have a very real cost. So from the beginning, we want to start to have an idea of what the various stakeholders expect to get out of this intervention. And this is quite important because it's what we can refer to at the end during the validation to see, did we create a system that actually satisfies what we were set out to do? And if not, well, then we can backtrack and find out what went wrong. Then on the bottom, we have the task. And again, this can start by just describing what the team is supposed to accomplish, breaking it down in subtasks and goals, but also it should capture a bit more information about the demands that the task will have on the operator and the AI system. So are we talking about physical demand as lifting heavy objects, or mental demand of solving problems, making decisions, and also how the task is affecting the interaction between the AI system and the operator. That is there an overlap between them? Do they need to cooperate in certain parts of the task and work independently in others? This is all things that we want to capture in the task. That's pretty much the wrong one. Okay, now we go to the core of the model. This is the team in itself, and the team is sort of split in two. We have again the two protagonists. On one side, the agent that is further split in the software part and the embodiment part. By embodiment, we mean all of those things that pertain to robotics and sensory systems, while the software part are more about perhaps the AI model that is running behind the scenes. On the other side, we have the operator, and in the middle, what connects them. Now here we have, if we start from the agent, we have some variables that are a technical description of what the agent is. We are trying to capture, okay, is it an LLM that powers a personal assistant, or is it, say, a computer vision algorithm that does sorting of objects? That should be described here. But on a more abstract level, we also want to know what kind of outputs we get from the agent. For example, the explainability that we are getting out. And also, is it trainable? Is it going to learn and be taught by the operator? And also, here we have the opportunity in the design stage to start to look at concept as the mental model of the agent. How do we want the agent to see the world and see the system that is put in, or also how do we want the agent to conceptualize the operator? How will the operator respond to inputs, and what motivates the operator, and all these things that are things that will sort of define how the agent reacts to the world and the operator, and that we should discuss in the design phase of a project. On the other side, we have the operator, and the operator is defined with, let's say, very common human factors terms. So we are trying to have a profile of who will engage with the agent. And this can be both in terms of capturing who are the workers that are already in a company that will become teammates, but also perhaps seeing what these workers need to become the optimal operator. So perhaps we will have to do training and reskilling to make them fit better in this framework. So this should be captured in the operator side. In the middle, we have the mediator. And the mediator is everything that allows the agent and the operator to interact. So we start from sort of a simple level of UI and UX, how the interface is made, how do they communicate, but also we have a layer that should describe how perhaps how procedure affect their communication. How do we solve conflicts? If the agent is proposing a solution and the operator is proposing a different solution, how do we solve this? This is defined as a procedure, and this will then sort of create a hierarchy and an authority structure of the team. So when we have these three things interacting, we arrive to the team and teaming side of the thing. And this is sort of divided into, and you could look at it as two sides of the same medal, because the team for us is an expression or a description of the emerging interaction between the agent and the operator. So we start to talk about concepts such as shared mental model, shared situational awareness, and shared goals. And these are things that emerge from the interaction of these two protagonists, but also there are things that we can in part design and say, okay, we think that in order to better engage in teaming, we need to have a certain type of shared mental model. But on the other side, we also will want later in the validation stage, we will want to see if what we desire, what we designed, is actually what is happening in real life. So then we start to talk about teaming as all the metrics that can let us measure teaming, so a manifestation of the teaming that we can actually look at, that we will consider in the validation stage. And I will touch upon this a bit later, but basically there should be a connection between concepts such as shared mental model that are not necessarily directly measurable and other things that are directly measurable, but that will let us infer whether shared mental model is good or bad. So now I can move on to the overview of how we are planning and or are actually applying the model in various use cases. And the idea is that, we would, if possible, start early in a project to apply the model. And we would start at the beginning by collecting context and requirement information. So in this stage, basically the teaming model is a container of information, and it guides us in collecting information. So it helps us while we are conducting workshop and interviews with stakeholders to ask the right question and make sure that we have a complete overview of what the teaming is supposed to be, at least for what is actually defined at such an early stage, and what are the requirements that the stakeholders have. And also the main output at this stage is that we are able to identify if there are things that haven't been discussed by the other stakeholders, and then as mediators, we can go in and ask the right question and elicit certain reflection from them. For example, if you take an example, one of HARTU's use cases, this is from TOFAS, we have a task where a robot and an operator are supposed to pick and place parts from a container. And so at the beginning of a project, we would go in and talk with the partner at TOFAS or also the technical partner that will perhaps implement the solution, and start to gather information of all the information about what the task is supposed to be. Perhaps document the as-is scenario, how the task is being now carried out by the operator on his own, and how the task is expected to be at the end of the project, the to-be scenario. And in this case, perhaps we have an idea that the task is still going to involve an operator. The robot should do most of the work, but an operator will still be there in some capacity. So we know there is a form of teaming, and we can go on with this information and refer to it as we go forward in the project. So after we have sort of solid basis of gathering all this information from the other stakeholders, perhaps we go through the design stage of a project. And in this stage, the model helps us as a repository of information because we refer to what we collected earlier, but also it helps us mediating the design. And I think a good example of the mediating process is the work that we have done with the definition of roles. The definition of roles starts from the need of being able to discuss in plain words with the other stakeholders and define what do we expect the two team members to do. And so we have created a narrative model of teaming, a narrative model of the roles that basically creates, or we try to map at least a comprehensive list of roles that the AI agent and the operator could have in a team, and allows us to do a discussion. For example, here again is for the example from TOFAS of what combinations could work. For example, here we had among the desired combination, we had an independent AI, so an AI that is doing most of the work, paired with a passive user, so a user that is almost not involved, or a collaborative AI that is doing a good part of the work, but then has to perhaps ask for help to an helper user when there is an unforeseen situation. So we had this discussion in a workshop with our partner TOFAS, and we tried to find out, okay, why are these the desired combination, and why are these the sort of the optimal combination that we might have. And also, if you see here in the list of roles that we propose, we also have a few that are definitely not desirable, such as a faulty AI and a clumsy user. And these are actually here to have a discussion on what happens when we have human error in our system. Is the system resilient to human error, or whether we have an AI that malfunction? Is the system resilient to malfunctions of the AI? So we can also have a discussion about those cases. So again, this is a narrative approach to the definition of roles. It's not producing requirements on the development of an AI system directly. It's more about having a discussion early on with the other stakeholders and imagine how the teaming can play out. And I think this is quite important because, as it has come up already earlier today, there is often a lack of discussion on what the operator will do. We end up having perhaps underutilized workers where the technology is sort of taking the first the spotlight, but this can create a situation where you have an operator that is not really engaged in what he is doing because we are only applying leftover allocation. If we early on have a discussion and we imagine how the operator will interact with the AI, then it's possible to have a meaningful relation between the two and actually have a teaming that is positive and sustainable. So after the design phase and after basically we have updated our model with all the things that we think we want, we have the implementation phase. And in the implementation phase, usually the technical partner will step in and translate this high-level teaming description into description of what is actually going to be implemented. So again, the model here is mostly being updated and going from a description of the design to a description of what will be implemented. And then, of course, it's up to us to compare the two and see if there are discrepancies. And finally, we have the final step, that is validation. Validation is about evaluating something that is being implemented. Of course, this can be at many stages. It could be a prototype, as it could be something that is actually being deployed. Depends on the project. But the main point is referring to what we have designed and see if the implementation is actually reflecting that. And the main use of the model here is, first of all, as a reference, because hopefully, if we have gone through the entire process, we have very clear requirements coming from the first two steps, but also it should give us an idea of which teaming variables are most important in a certain scenario. So, for example, again, if we believe that shared mental model, a certain shared mental model is of particular importance, and this is quite often the case because shared mental model is one of the variables that really enable teaming with multiple team members, then we might want to organize a validation plan that includes some things that can make us infer, that lets us infer if the shared mental model is structured correctly. But since shared mental model is not something that can be measured directly, then we look at things like adaptability, whether the team is able to adapt to different situations quickly on the fly, or their communication. And the model is also suggesting this connection. And so it's used to translate high-level concept into concept that can, or actually not concept, but variables that can be measured in the field. And finally, on the validation, I would like to add that we are not only looking at human factors variables, so we're not only talking about mental models and workloads and things like that, but the validation should include also requirements that relates to KPIs, productivity, safety, legality, and ethics. And all these things are hopefully captured in the task description and the environment description so that we have a reference to compare our results against. I think that's about it. Maybe a bit over time, but just to summarize, we think that human AI teaming interaction model can be quite beneficial to many of our projects because it allows us to have common understanding with all the stakeholders and discuss teaming early on in simple words, find issue early, and also have an idea of how we can modify our system to affect teaming and correct this issue. It also should support good discussion that make us design teaming that is flourishing. So create meaningful roles, create meaningful task allocation, and also it should help us validate and plan should help us do validation planning and also iterative design so that we can improve our design over and over. And well, I think that's all.